CVC product's electron beam evaporator is used to coat samples with various metals. Unlike sputter films, evaporators only coat the surface facing away from the substrate. Evaporators will provide very little coating to the sides of any features that are perpendicular to the surface of the substrate. The E-beam is usually used for titanium, chrome, gold, nickel, platinum, aluminum, and copper coatings. It can be used to evaporate most other metals as well. The E-beam evaporator can hold up to 6 different evaporation sources. A cryopump is used for rapid pump down. The E-beam can process samples in size from 4-inch wafers to less than 1 centimeter squared samples using the process plate. It can also process 23-inch or less samples using the process dome. It is also to be noted that the backside heater is disabled. In a typical process, the chamber is pumped down to a pressure of 5 times 10 to the negative 7 torr to prevent air molecules from interrupting metal atoms as they travel from the evaporation source to the substrate. The metal evaporation source is then heated to a high temperature by a beam of electrons. This causes the metal to evaporate and be deposited on the substrate. Typical deposition rates range from 2 to 5 angstroms per second. Let's now introduce our lab users. We will now go over the various parts of the E-beam evaporator. We will begin with the ion gauge. It is used to display the chamber pressure when the chamber is under high vacuum. The pressure is measured in torrs. The valve controller controls the valves that are used to control the chamber pressure. The gauge in the middle of the controller shows the chamber pressure in torr. The lights on the left side of the gauge show that a valve is open when the respective light is on. The crucible selector moves the selected crucible into position for evaporation. The power supply controller controls the electron beam power supply. The XY sweep controller controls the position of the electron beam. For proper operation, the beam must move in a circle inside the crucible. The beam should not touch the edges of the crucible. The shutter control opens and closes the shutter. Usually, the shutter is controlled by the deposition monitor. The shutter is closed while the metal is being heated. Once the metal is evaporated at the correct rate, the shutter is opened, exposing the sample to the evaporation. Once the desired amount of metal has been deposited, the shutter is closed to prevent further deposition. The hoist control raises and lowers the hood. The deposition monitor shows the rate and deposition thickness of metal being deposited onto your samples. The monitor is also used to choose the recipe you want to run. We first want to go to the automatic valve controller and press the stop button and then the vent button. We will then wait a few minutes for the system to vent. Wait until the needle on the chamber pressure gauge reaches the right side of the display. We can tell the chamber is vented by either waiting for a clicking noise, a hissing noise, or by actually feeling the nitrogen gas coming out of the chamber by the seal. Once you hear the clicking noise, push the stop button to close the vent. Then press the hoist up button on the hoist controller in order to raise the chamber all the way. Do not try to hoist up the chamber before the chamber is completely vented, and be sure to use the hoist up button instead of using your strength. Clean the area by vacuuming any flakes or debris that have been left on or around the chamber. Cleaning the area helps create a better seal between the metal and the rubber. It is very important to vacuum the area. Do not forget to do it. Next, check the mirror that is located directly above the shutter. If the mirror is dirty, remove it and replace it with a clean mirror. Check to see if the shutter is working properly. Go to the shutter controller and select manual mode on the manual auto shutter button. Then test opening and closing the shutter by pressing the shutter open close button. Set the manual auto shutter button back to automatic before going on. Now we go over to the crucible selector and select our evaporation source. In our case, we are using copper, so we press the copper button and wait for the light to turn on. This tells us that the crucible is in the proper position. However, you still need to check the crucible to see that it is aligned properly. You might need to first move the shutter out of the way in order to see the crucible. Then make sure the crucible is in a V alignment. First, get a sample holding plate and place a screw in it. Then place a sample holding clip around the screw and tighten down the screw. Repeat this process for at least one more screw. Then place your sample on the sample plate and put the clips on top of the sample. This holds the sample in place. Then place your sample plate on top of the sample holder. Be sure to place your sample facing down. Now hoist the chamber down by pressing hoist down on the hoist controller. Once it has been hoisted down, press the start button on the valve controller. This will start pumping the pressure of the chamber down. After a few minutes, the chamber pressure needle will start moving and go down to about 0.5 torr. The high vac light will then come on, indicating that the valve is open for the cryo pump. Soon after, the ion gauge controller will come on. This is indicated by the lights on the ion gauge controller changing from red to green and the counter displaying the decreasing pressure of the chamber. We will wait for the pressure to come down to about 5 times 10 to the minus 7 to 2 times 10 to the minus 6 range. However, if you are not concerned with the deposition quality, you can start at higher pressures. If you want a low pressure, it may take 30 to 45 minutes for the system to reach the pressure you want. Do not leave the area while waiting for the chamber pressure to decrease. You must monitor the E-beam to ensure that the system is functioning properly.